Okay, now we're going to look at another approach for setting the control limits. Now this approach that we just looked at in the previous video relies on we knowing the value of sigma sub x, the standard deviation of the production process. So if we know the standard deviation of the production process, then we can divide by square root of n and we can use this formula. In usual cases, that may not be available. If that is not available, computing standard deviation from the sample is, you could do that, but typically in statistical quality control situations, the preferred approach is not to use this formula, but use a different formula that's not to use this formula, but use a different formula like this one. Okay, so here you note that the first part is the same as the previous formula. You still have the x double bar, but instead of sigma over square root of n, we have the range bar. So from each sample that, okay, remember we in the at the stage of developing the control limits, we repeatedly sampled the production process in reasonably quick intervals, small samples, 3, 4, or 5, or 6, maybe 10, okay, every 15 minutes or every half an hour, and you repeat that 20, 30, 40 times. So you have that many samples. From each sample, you'll get a sample mean, and if you average all those sample means, you get the mean of the sample means, which is x double bar. So that goes in there, okay, and then from each sample, you find the range. Okay, so range from sample 1. Range is what? The largest value minus the smallest value. Okay, so from each sample you find the range. So you'll get R from first sample, R from second sample, R from third sample, and so on. And then you average all those R's, then you get the average of the sample ranges. Okay, so in place of sigma over square root of n, you'll use R bar. But then when you do that, you can't use z anymore. Okay, and we have to use a factor called a sub 2, and that factor is available in a table. Okay, so like that. So table 15.2, this is in your book. Okay, so here is the sample sizes. Okay, remember the repeated samples, so you have to be very careful. What is the size of each sample? That's what determines the factor. So you get the a sub 2 factor from this table, okay, and plug that in. Okay. Now this table is based on 99.7%. So here, if you take this approach, it's 99.7%. That's it. You don't have the choice of z equal to 2 or z equal to 3. You have to use z equal to 3. And that is the basis upon which this chart is developed. So you plug that in. Okay. So that is your x bar chart. And this table also gives you two more factors, d sub 3 and d sub 4, which are used to develop the lower and upper control limits for the chart for R. Okay, remember we have two control charts that go as a pair for variables. You have the x bar chart and the R chart. We looked at x bar chart using sigma over square root of n, which is not usually the common situation. Okay, that's kind of unusual. Or with a sub 2 times R. Okay, and then you have the R chart also that needs to be developed, and the factors d sub 3 and d sub 4 are used for that. And here is the formula for that. The upper control limit, you use d sub 4 times R bar. The lower control limit is d sub 3 times R bar. So suppose here is an example, super cola bottles are labeled net weight 16 ounces. So the overall process mean is 16.1, x double bar. So you've taken many samples, and each sample you found x bar, and then x double bar turned out to be 16.01. And then you also found the average range to be 0.25, and each sample was size 5. Then you substitute 16.01. Now the factor a sub 2 for n equal to 5 is 0.577. So plug that in and you get your lower limit and upper limit. Now R bar is 0.25, So again, for 5, the factors are 0 and 2.114. So if you put 0, you get lower limit, 2.114, you get the upper limit. Okay, let's set up the problem in Excel. So overall samples, each sample is of size 5. Overall process mean is 16.01. Average R bar is 0.25. Now for 99.7% confidence, A sub 2 is 0.577. So that's Z equal to 3. That's the only confidence level that's possible. A sub 2 times R bar, so it gives us the sampling error. So that's our estimate of sampling error. Once you have the sampling error, then we can do the lower control limit is overall mean minus the sampling error, and then overall sample mean plus the sampling error gives you the lower control limit. So the upper and the lower control limit. Now D sub 3 is 0 and 2.114 is the factor. This is for n equal to 5, the two factors for the range control chart. So the range control chart lower limit is D sub 3 times R bar, and then D sub 4 times R bar. Okay. So this is how you would establish the control limits for the X bar chart and R chart, which are called the variable charts in statistical process control.